Hey everybody, my name is Ernesto Vasquez, and hopefully this thing started recording. Yes, it did. I'm making a video for cybertitans.org, and in this small series I want to talk about subnetting for Cisco. I'm going to take it step by step. I'm going to start out, I want to start out with how IPs work and work our way up to breaking them apart and subnetting them into smaller networks. So what is subnetting? Subnetting is basically taking a block of addresses or a chunk of a network or a network period and breaking it up into smaller networks to fit different environments or different needs and to do it as efficiently as possible. That's the whole point of subnetting. Okay, there's two types of addresses that we use. Okay, for the most part, everybody at home has it. There's class A, so I'm just going to type this out, class A. There's also class B, and there's class C. Okay, and this is known as class full. Let me put it up here somewhere. This is called class. Yeah, there we go. This is called class full addresses. That's spelled wrong still, seriously. There it is. This is called classful addresses. So basically a classful address, there's characteristics to it, okay? So as you know, every address, it's going to look something like every address, okay, let me back up. Every address, IP address is used to connect from one device to another over layer 3, which is the network, okay? Now, the way it works is there's such thing as private addresses. These are addresses that are in the home or for use in private networks or there's a difference between a private network. Doesn't mean it's from just your home. It could be a business or a corporation. It's a block of addresses that's set to a private that anyone can have. You can have, let's say you have a class C address of 192.168.1.15, let's just say, just some random number, right? Here's an IP address, right? Every IP address also has a subnet mask, alright? And the subnet mask for a class C is always going to be this, 255.255.255.0. Okay, that's the subnet mask. This subnet mask down here, I'm actually going to use this one. This subnet mask down here, basically what it does is it tells you how much of this IP address is part of your network and how much of this IP address is your host. So in this case, you see how the 255.255.255 and then there's a .0. That's indicating that this part of the address is your network and just this last part is your host. So each one of these is called an octet, right? Why is it called an octet? Because every single address is made up of bits. Okay, so 192.168 or 10.10.0. whatever or 2, whatever the number is, those are just numbers so that we as human beings can understand them. Alright, so computers don't understand this. All they understand is binary, which is a base 2 number system. Okay, so the base 2 number system it's either going to have a 1 or it's going to have a 0. Those are the two states. So it's only on or it's off. It's a yes or a no. It's a true or a false, or what's called Boolean. Alright? So these numbers are a translation of that. So this is human and then this is computer. Alright? So what does this address look like in human address, right? We're talking about class C address here, okay? So 192.168.1.15, okay? So the first thing I'm going to talk about here also, and I'm jumping around a little bit, but just bear with me, it'll make sense soon enough. So the first thing I'm going to talk about here is converting from decimal, that's these guys right here, that's these two right here are decimal, into binary. So this is going to be whatever, right? Binary, zeros or ones. Alright, how the computer understands them. Okay, so how do you convert from decimal to binary? I gotta go through all this so you guys can understand subnetting. That's how it works. Okay. So because it's a it's a base 2 number system. It's set like this. Okay, starts out with 1. So these are number places, right? Then it goes, let me just count some even number here. 1, 1, 2, 3. Maybe there's a better way to do this one. I could do this better. Just go back here. Alright, so it goes like this. From left to right, it goes the highest number in binary, because there's 8 of them, right? So they're supposed to be, so this is called an octet because there's 8, and there's 8 bits in each one of these numbers, right? So this is what it looks like. So these are place values, okay? So it's going to be 128, 64, 32, 16, 8, 4, 2, 1. Ah, I missed it by 1. 1, there. Ah. Man, why it's gotta be so hard? Okay, here we go. 128, I'll just do 1 tab. 64, 32, 16, 8, 4, 2, 1. Okay? So 1, 2, 3, 4, 5, 6, 7, 8. Right? 8. There's 8 place values. These are just places, okay? And then we give values to these. Alright? So, how we do this is, whenever you're talking about a bit value, if one of these is a 0, and then let's say this one is like a 1, right? So this 0 is placed with this 128, this one is this with this 64. Let's say I'm just going to make some random ones. Here's a 0, here's another 0, here's a 1. Let's make this a 0. Here's a 0, here's a 0, here's a 1. Alright? So these are the place values, and this is the actual binary number down here. Okay? So basically how it works is, whatever is a 1, that means it's turned on, right? Because it's either on, a 1, or it's off, a 0. Right? So basically, if it's a 1, we use that number, and if it's off, we don't use it, right? So right here, a 0. So is this on or off? Off, right? We don't use it. A 64. Is that on or off? It's on, right? So we do use that. So we have a 64 plus something else, right? None of these are off, so none of these get used. But this one is here used. So this place value is used. So it's 64 plus 1, which equals 65. Right, 65. So this entire, these 8 bits right here, like 0, 1, 0, 0, 0, 0, 0, 1, that means 65 in decimal. Okay, so the computer understands these 8 pieces of information, these right here, as to us meaning 65. That's basically how it works. That's all there is to that. All right, and just for so you know, each individual one of these, every one of these is called a bit. Okay, it's called a bit. All right, 8 of these together, it's called a byte. So 8 bits is a byte. And for some of you that don't know, 4 bits is called a nibble. So it's a bit, a nibble, and a byte. All right, and since there's 8 of them, right here, it's this is 1 byte of information, right? Or 8 bits here. Here's another 8 bits here. Here's another 8 bits here, and here's another 8 bits here. Okay, but we call when we call these octets. So this is the first octet, second octet, third octet, fourth octet. Okay. Alrighty. So why don't we convert this number into binary? Right. We're gonna convert that number into these individual numbers into binary. Sorry. Okay. So that first one, I'm just gonna delete these right here. I'm gonna delete this stuff also. Actually, take this out. Whoops. And it's supposed to be a 1 there. Okay. Here are my place values. We're gonna convert these into binary, right? So the first number is 192. What numbers, starting from the left, what can you add to get 192? Well, right off the bat, you know that 128 plus 64 equals 192, right? So basically, only these two need to be turned on. All the rest of these are going to be 0. There. So now we have our first octet. So for 192, the octets look like that. Okay? So you can even do the math. 128 plus 64 is 192. Bam, right here, 192. So this is our first octet, right? So it's going to look like this. I'm going to do it up here. It's going to be 1, 1, 1, 2, 3, 4, 5, 6, 7, 8. Oops, that's not how you do it. 1, 1, 2, 3, 4, 5, 6, 7, 8. Dot something, right? Let me move this over a little bit more. This guy over more too. There. So that way you can kind of see how it's supposed to look. Alright. So 1 something. What about 168? Let's convert this number into binary also. So we're gonna need 128. So it's gonna be a 1 down here. Oops. It's gonna be a 1. I'm just gonna kind of speed this up. You don't need the 64. You do need the 32. You don't need 16. Like that. There. Okay, 128. I'll even bust out a calculator here. There we go. So, let's see right here, 128 plus, let's do it like this, 32 plus 8, 168. There you go. Because this is turned on, this one's turned on, these two, and these two. Okay, so it's gonna look like this. 1, 0, 1, 0, 1, 0, 0, 0. Dot something. Right? And then we have the 1. So for the 1, down here, it's pretty self-explanatory by now, right? All these are going to be turned off. Except for this one. Right? So it's going to be 1. 3, 1, 2, 3, 4, 5, 6, 7, 8. Dot. And the last number, 15. What do we need for that? Right, so we need a... we don't need the 128. I'm going to do it down here so you guys can see me do it. So 15. We don't need the 128. We don't need that. We don't need that. We don't need that. We're going to need that. Plus 4, 8, 9, 10, 11, 12. That's 12, 13, 14. And one more is 15. There. So it's going to be 1, 2, 3, 4. 1, 2, 3, 4. So 1, 2, 3, 4. 1, 2, 3, 4. Alright. So now we can see that this 192.168.1.15 translates in binary to these numbers. 11.00000.101.0000001.0000001.0000011. I may have said a couple ones or a couple zero, but you can see that here. All right. So now these numbers have been translated into this, right? So now what about the subnet mask? So remember I told you how the subnet mask determines how much of this address is part of the network and how much of this address is part of the hosts or the devices that are available, usable addresses, basically addresses that are available to be passed out, not necessarily devices, but addresses that can be assigned to devices if needed. So, you know, technically if your hardware supports it, yeah, you can put devices to every single one of those. Alright? Oh my goodness. Okay, so 255.255.255. The thing about the number 255 is the number you take when all these numbers up here, every single place value is added up. Okay, 1 plus 2, 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128 is equal to 255. So this will look obviously like this, going to look like 1, 1, I messed up, 1, like that, right? So if I move this guy down a bit, so let's take this number, let's take the subnet mask and take it apart. That's not how I was doing with the other guys. Alright. So it's going to look like this. 1, 2, 3, 4, 5, 6, 7, 8. Dot 1 dot. Separate it a little bit. 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot. And this is a 0, so it's going to be 8 zeros. It's, even though it's a 0, it's still 8 bits. It's still 8 pieces of information, right? 8 bits of information. So be 1, 2, 3, 4, 5, 6, 7, 8. So this is what the subnet mask looks like, okay? So this is decimal notation for the subnet mask. Excuse me. And in Cisco, there's 2 ways you write subnet masks, okay? Or net masks, whatever you want to call it. Net masks. So one is your regular decimal notation, 255.255. There should be a dot right here. Dot 255.0. That's one way. The other way is we use something called we like to pronounce it CIDR notation. CIDR notation, but it stands for classless inter-domain routing. That's what it stands for, classless inter-domain routing, and that uses slashes. So you'll see an address. So instead of saying, "Oh, my address is 192.168.15 and my subnet mask is 255.255.255.255," instead of saying my subnet mask is, or my net mask is, you say, "Oh, my address is 192.168.1.15/24." Okay, so the /24 is your subnet mask or your net mask, and that this 24 is the same thing as this specific subnet mask of 255.255.255.0. Why? Because if we convert these decimals into binary, right, we're using 24 bits for the network, right? It's 24 bits that are used at 1, 2, 3, 4, 5, 6, 7, 8, right? 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 ones, right? So that's why we say /24. And that's why this is part of your network. So what does that mean? That means since all these bits are turned on, right? That's the first octet, the second octet, and the third octet. So that means that this octet right here, the first octet, this second octet, and this third octet are part of your network. Alright, and since this is a 0, alright, we say that the definition of this network, so this is host 15, right? So this number 15 was just handed out to some random device. So this is all zeros, this is a 0 right here. This is called the network definition. This is the name of the network. Okay, so this is the address for the network. Okay, so this is the first address in the network, which is the network definition itself. So that's why whenever you have, let's say you have 256 in a class C, you can't use 256. Why? Because you can never hand out your first address and your last address, because the first address is used for the network. It's the network definition itself. And then the last address is 255. So the last address is the very last number on that network. Okay, so basically what this does, it's called a broadcast address, and that's used to broadcast to all devices on that network. So the first address defines the network, and the very last address broadcasts information to everybody on the network. So that's why you can't use it. So okay, so that's that. Okay, so this is back to 15 because this is an individual host, right? Okay, so this is basically why this address is called /24, not b/, just /24. Why did I keep pressing that button? slash 24. All right. So what if this said, so that's that, right? Let me just stick with one thing here. Okay. So I know I was going to talk about Class A and Class B. I'll get to that. I just want to concentrate on what's familiar to everybody in everybody's homes right now. So everybody in your houses, it's going to be a Class C address. And it's also called a slash 24 network. Okay, when you're talking about classless, and you can have any number. You can have a slash 2, 22. You can have a slash 21. You can have a slash 20. What does all these numbers mean? You can have a slash 27. All that means is when it comes to the subnet mask, that means that how many bits are turned on. So let's say it's a slash 27 network, right? Let's say you still have this address, right? But it's a slash 27. What does that mean? That means 27 of these bits are going to be turned on. So we know up to here is 24, right? But then we borrow bits from here to complete 27. 25. What the hell did I just do? 1, 2, 3, 4, 5, 6, 7. Okay. So I'm missing a place right here. There goes 1, 2, 3. So we have 24 here, 25, 26, 27. And all you have to do to find out the new subnet mask in decimal form is convert these binary bits back into decimal, right? So we have 3 of them that are turned on. So we go down here and we say this one's turned on, this one's turned on, and this one's turned on, right? So then we add them up. Bust out my calculator right here. It's better if you learn these additions by memory. I know I haven't, but you know, it behooves you to do so. You know, do as I say, not as I do. I'm just kidding, but I'll get them. I'll learn. So let's just do it. How about that? 128. 128 plus 64 plus 32, and that's it, right? Those are the only bits that are turned on. 224, right? So the subnet mask is 224 for this particular network, right? So a slash 27 in this particular case is going to have a subnet mask. When it's a slash 27 network, the subnet mask is 255.255.255.224. Okay. So we're talking about a slash 24. So this becomes a 0 because none of these would be turned on. 1, 2, 3. 1, 2, 3. Okay. That's basically that. Phew. Okay. So what have we learned so far? Let's review really quickly because I feel like I'm just talking and talking. So let's just review. Number 1. All IP addresses are required to be, I'm totally wording that wrong. Number 1. In order to communicate between devices, every device has to have some sort of an IP address, right? And it has to be handed out either manually or automatically by a DHCP server. So a DHCP server just hands out addresses basically. So again, what did we learn? In order to communicate with anybody or any device, you have to have an IP address. Just like when you go to the post office and you're sending out a letter to somebody, you need a country, a state, a city, and a specific address, right? So these numbers, right? So these numbers define what part, like let's say, so this is your network, right? Not the 0, the 255.255.255, that's your network. That's like being your city or your neighborhood, right? Your neighborhood. Let's say in my neighborhood is 1232 West Jefferson, right? And that's actually kind of my address, but not really, but somewhere around it, right? And then my host, or this 15 right here, not the slash 24, because that's another way of saying slash 24 again is another way of saying this, which is something else that we learned. But this 15 is my host, or it's my apartment number or my house number basically, right? Or your device specifically. And this right here is your neighborhood or your network, right? So so everybody on your network is going to have this much of the address that's going to be the exact same. The only thing that's going to change per device or every time an address is assigned out is this one right here, this last 15 right here. Why? Because these are your hosts and these right here are your network. Okay, so that's one thing. Number two, there's two ways of writing a net mask. A net mask is written as this in decimal form, 255.255.255.0, or it can be written in CIDR notation. We're going to be working more with CIDR notation, so that's this right here. And this is equal, not this whole thing actually, this whole thing is equal to this, which is /24. Number three, CIDR means classless interdomain routing. And basically what that is, it's going to be the opposite of having a class. So this is class A, class B, and class C. Class A is defined as being a /8, right? So only the first octet is turned on. So your subnet mask would be 255.0.0.0. Okay, so in a class A is in CIDR notation, it's called a /8 network. So you have some kind of an IP address with a /8 at the end, right? So class A is /8. Why? Because a class A net mask looks like this, 255.0.0.0. Excuse me. Class B, let's leave that there actually. Class B is called a /16 network. Okay, and then there's everything in between, but for the class, it's class A, class B, and class C. We have these. So class B is going to look like this. So the subnet mask for class B is 255.255.0.0. All right, and it's a /16 network. All right, and class C, we know that it's 255.255.255.0, and it's a /24, and it's a /24 network. Okay, so class A is a /8 because only 8 of these bits are turned on. Class C, you have 16 bits that are turned on, and class B is 16 bits, and class C is 24 bits. Okay, so those are your standard, and then there's your in-betweens, which would be like class /7 network, a /6, a /22, a /20, a /7. Take your pick, you know. And all that means is how many of these bits are turned on from left to right, right? So if you have a /3 network, it's going to be like that much. So only this part of is your network, and then everything else is going to be your IP numbers that are available to be handed out. So that's going to be a gigantic number of IP numbers. Okay, that's what that means. All right. Another thing that we learned is that IP addresses are written in what's called decimal form. So your regular numbers, so we can understand them, but the machine or the computer understands only binary ones and zeros, right? So 110000 is 192. This is 168. This is a 1, and this is a 15. Why? Because each one of these ones or a zero has a place value. So these are exponents. So this would be a 1. This would be this is a 2. 2 to the 2 is 4. Right? So it's a 2 to the 3 is 8. 2 to the 4 is 16. And so on, 32, 64, 128. We only need up to 128 because we're only using 8 bits. Because each one of these octets is 8 bits. So the entire IPv4, which by the way, these are IPv4 addresses, which is Internet Protocol version 4. When they say, hey, how long is a IPv4 address? You say, oh, it's a 32-bit. It's 32 bits in length. Why? Because all of these are 32 bits. So it's a 32-bit length address. Okay? That's what that means. So for each octet, we're converting. So there's 8 places, so we only need up to 128. So these are your place values. And this is basically what you use to figure out why is this thing here? Go away. Go away. Whatever. So this is what you use to convert these decimals into binary, okay? And whatever is a 1, if there's a 1 under it, that means it's turned on and it is used in the addition, and if it's a 0, it's turned off. Okay, so I think that's it for today. In the next video, I'm going to talk about, give you ranges for these addresses, which you can Google now if you want. Class A, Class B, and Class C, and we're going to talk about, get more into the subnet mask and how it's subnetted, and how we can subnet it, how it's used. Okay, so digest this for now. You know, do a little research, little bit of research on your own, but this is the basis, this is the beginning of subnetting. You have to understand how to convert between binary and decimal form. That was the main focus for this lesson, is the knowing that these are really binary, all right, for the computer. That's the main focus, this, and then the /24 or the /10 or the /22, and what that means. So that means that 10 of these or 22 of these are turned on, and whichever ones are turned on from left to right is the network, and everything else to the right of that is going to be your host or your available or usable addresses -2. Why? Because you don't give away your first address, which is your network address, your network definition, and you don't give away your very last address, which is your broadcast address. Okay, so that's it for today. I'm going to make another video tomorrow, hopefully, and then we'll talk about how a router and how a Cisco router recognizes what the network definition is and how to subnet it. Okay, so that's it for today. Digest this information. We'll take it a little bit at a time. Practice on your own. I think there's a game you can play. Let me see. Let me bring something up. It's called the Cisco binary game. And I've been known about this. We've known about this since forever. Let's see, one of these is good. Over here. Okay, nothing happened. That's crap. Let's see. Well, it's this one right here, but I want to see the actual. This is a document. I don't think this is it. Oh, here it is. That is it. So here's the website. Oh, you have to log in. Seriously? Ugh. Well, anyways, you should have an account. You know, and if you don't have one, talk to your coach. Certain people should have an account, if you know what I mean. Log in using that account, and yeah, you should be Netcat account. All of you should have one. So, you know, log in, play this game, and it kind of shows you, it gives you some addresses, and you have to put the binary to them or whatever. Blah blah blah. Practice however you can. You know, look for something, and practice this stuff. Okay, so just binary equals decimal, and this is what a network is, and this is what your addresses that you can hand out to people, or not people, devices that are available. Okay, so yeah, so my name is Ernesto Vasquez again, and this is a video for www.cybertitans.org. Again, that's www.cybertitans.org. Don't forget to register on that forum. Post up comments. If you find research and you find something interesting or better, please post it up there. It's a great way to just have information out there and share the knowledge. Alright, everybody, peace.